if you can hear me, clap once. If you can hear me, clap twice. I love this extra image that was added here. We'll get into that when I talk about induction. Because when we talk about induction and conduction, we generally, in our everyday life, think about it in terms of transferring of heat or insulating the heat or the cold when we're drinking something. But let's start with friction. So we did a bunch of labs, several in fact, where we used fur or plastic to create a charge. Our focus today is how we charge up objects. Generally, things are going to be neutral, but we can charge by friction, where we did the friction on the plastic rod, or we charge these pitons, which are neutral, and they're also insulators, but if we wanted to build a charge, we could through friction. Not as easily through induction or conduction, because insulators don't like to absorb or transfer charge, but definitely through friction. So, another example that was given to me last class, you experience shock because of generally the rubbing of your feet, your socks, or your shoes against carpet, and depending on the material, depending on the air, the dryness of the air, you can build up charge through friction that way as well. There is a very specific, and I didn't use that vocab word because I knew that it would be a hard one to recall, but if you look at your list, and feel free to write in this list as we go over these vocabulary words, under number 9, triboelectric charging, is charging by friction. We also saw a video, the gas station video, where the woman's friction against her seat created some static electricity, some static charge, and she ended up causing a fire in that fuel tank because that tiny little shock caused it to that fuel to flame. The next one. Are there any questions on charging by friction or triboelectric charging? Okay, so you've got induction and conduction on your list as well. I think it's on the back. 14 and, 13 and 14. So induction, and there are no words here, but these two charged objects aren't touching. So induction is specifically no contact. And when you have no contact, generally the two objects that are brought together, they're not going to transfer charges, but what's going to happen is that these positive charges here are going to attract the negative charges, because opposites attract and like charges repel. So what I'm going to end up seeing is instead of all these negative charges kind of evenly distributed, I'm going to show all these negative charges moving closer to the positive charge. You might have a few positive charges here, but we want to show that negative charges attract. Now, protons generally don't move. They stay within their atom. So the protons are going to interact, but let's say there were some negative charges here. If there were any negative charges here, they would repel the negative charges over here. So these negative charges would want to go all the way out to the very left. Now, for induction in terms of temperature, we don't do a temperature unit in this class. You talk about it a little bit when you are in chemistry, but we generally think of an insulator in terms of our insulating cup. This cup will hold in my cold, even my ice water for a long time. It'll stay, even my ice will stay ice till the end of the day because it insulates. It holds the cold in. This is more in terms of insulator, but an inductor, you can have an object that doesn't transfer heat, and you can touch something hot and you won't feel any of the heat. Same thing as insulating cup. You can touch maybe your mug of coffee and you won't get burned because the cup isn't insulated. Any questions on induction? The key here is no contact. We're going to talk about this in a little bit, but generally with induction, you've got the negatives on one side, the protons on the other. Can anyone tell me what that vocabulary word would be? If I have all the protons on one side, all the electrons on the opposite. Anya. Polarization. Whenever you have a separation of charges, we call it polarization. And generally, with induction, you don't have charges transfer necessarily, but you definitely have them polarizing. So I'm just going to go over one other concept because I think this is a good review. If I were to touch this, what's going to happen to those electrons if I'm touching something that's polarized, Greta? The electrons, they're going to want to go as far away from these because like charges repel. So these electrons, now that I've touched it, they're going to start transferring because they can move even further away from that negative charge. And then, through my body, and what is that called? Well, this is grounding. So a lot of vocabulary words that we talked about. We've got polarization, which is in your list, number 10. We've got grounding, which is number 15. Anytime you have an excess of charges or maybe a positive charged object, you can ground it by touching it, and any extra electrons in the ground will transfer in to make it neutral, or any extra electrons in the object will be grounded into the ground to make it neutral. So grounding, usually it's the earth, but it is an endless reservoir, I don't know how to spell reservoir, of charges. Charges. And it can take and it can take or add charges to any object that is touching it. The last one is conduction. Conduction is when we actually have physical contact. So I've got a positively charged object here. What I want to show is that this positively charged object is going to touch contact. It's going to touch this negatively charged object. I know it's negative because it only has 2 protons and a bunch of electrons. So what's going to happen in that contact? I kind of went over it here. What's going to happen once they are in contact, assuming that they're both conductors? Tanya? These electrons are going to distribute. They're going to start moving into this positive charge because the negative charges in that contact are going to want to go toward this positive charge. Now, they're actually going to evenly distribute. So if I have 1, 2, 3, 4, 5, 6, 7, 8 electrons, they're just going to distribute evenly in this object and this object, so that in the end, we actually end up probably with mostly positive charges. But one thing I want to emphasize is that can positive charges transfer? Ever? Never. You never transfer positive charges. You only transfer electrons. So if I have a positively charged object here, if I wanted to turn something a positive charge, I would have to remove electrons from it in order to make it positive rather than add protons to it. Does that make sense? Any questions on this? A lot of review. This worksheet is also my way of reviewing a lot of those concepts, what an electron or proton is, how an object is positive, negative, or neutrally charged. So this is something I'm going to have you work on if you finish the worksheet early, and finish it up for homework. But we didn't cover all these definitions. I tried to throw in all the definitions that I could think of. I probably missed some. So we covered most of it. 1 through 16 is the ones that I want you to do today. And then we'll cover 17, 18, and 19 later. Any questions? Okay.